Hello and welcome to AC Electronics. This is a part 3 of LPAC Technical Assistance Solutions. I was receiving a lot of requests to complete the questions and do the problems also. Okay, so here it is. This is a part 3 of solutions of LPAC Technical Assistant Examination, which happened 2-3 days before. Okay, so the first question is this. In a series RLC circuit, that is in series RLC, R is equal to 1 kilo ohm, L is equal to 10 micro Henry, C is equal to 1 microfarad and the source voltage is 10 volt. The current in the circuit at resonance is dash. So this term at resonance is very important. Okay, so during resonance, what is happening? The circuit is becoming purely resistive. The impedance is only caused by the resistive component in the R, L and C. So what will happen is that the current is actually contributed by the resistive element. So you can write I is equal to V by R. Earlier it was the combination, the resistance is a combination of R, L and C. But here at resonance, what will happen is I is equal to V by R. The source voltage is 10 volt, right? 10 by the resistance value, which is 1 kilo ohm. So it will be 10 milliampere will be the current at resonance, and this is the peak current, because what happens is that at resonance only this resistive element will be active. The other elements are not contributing to the total impedance. So what will happen? The resistance is at its minimum value, the current is at its peak value. So we have discussed all this while discussing the curve of resonance peak. Okay, anyway, the correct answer here is option A, which is 10 milliampere is the correct answer. Also, I want to tell you that there can be some small mistakes because the answer key is not out. So there can be some small variations in the answer or small correction on the answers. So if you found that this answer is wrong, please do mention in the comment section. Okay. Anyway, I'm trying to Google and find all the answers and make the answers as correct as possible. Anyway, there can be small errors. Okay. So, moving on to the next question. Let me remove this first. A copper wire is 1 meter long, length is 1 meter, and has a uniform cross section of 0.1 millimeter square. The resistance at room temperature is 0.171 ohm. What is the resistivity of the material? Okay, the equation you have to use here is R is equal to rho into L by A. And from this, rho is equal to R into A by L is the equation. Right? This is a very basic equation. And in this equation, you have to substitute for R, A and L. Okay, so what is the value of R? It is 0.171 ohm into A, area is 0.1 millimeter square. You have to convert it in meter because all the answers here is in ohm, meter. All values are in meters. So we have to convert the millimeter square into meters. So it is 0.1 into 10 raised to minus 3. It is square. So 10 raised to minus 3 square. That is, it will be 10 raised to minus 6. It will be, right? 10 raised to minus 6 by length is 1 meter. Okay, so how can you write it? This is rho and the resistivity you need to find. So 1 meter you can cancel because it is 1. And also if you see the answers, it is in 1.71. So it is 1.71 into, so again from here there is a 10 raised to minus 1, there is a 10 raised to minus 1. So it is 10 raised to minus 6 plus 2, that is 10 raised to minus 8 ohm meter. This is the answer for the resistivity. Okay. So the equation you have to use here, the general equation is R is equal to rho into L by A. So from this you can find resistivity, length and area. The relation with the resistance is R is equal to rho into L by A. Okay. Correct answer is 1.71 into 10 raised to minus 8 ohm meter is the correct answer. Next question. Q factor of a coil is dash. It is omega into L by R is the Q factor of the coil. Omega is the angular frequency, L is the inductance of the coil, R is the resistance. And if the options is given as 2 into pi into f, then this is how you represent it. That is 2 pi f into L by R. Okay. So the Q factor of a coil is generally given by Q factor. Please note this down. It is omega into L by R, or you can write omega as 2 pi f L by R. This is the equation. 2 pi f into L by R is the equation for Q factor of a coil. The next question is this. Tunnel diode is a dash. Answer is heavily doped PN junction diode. Tunnel diode, the basic thing is that tunnel diode is a heavily doped PN junction diode. The options can be high resistivity diode, slow switching diode, etc. And also in the option it was given that it is a heavily doped PN junction diode. You have to choose this. It is a heavily doped PN junction diode, and this is the symbol of a tunnel diode. Okay. Set of questions is this. What is the change in resistance of a copper wire when the wire is stretched by 5 times and diameter is half? So here we are going to apply the equation for resistance. The resistance of a conductor depends on its resistivity, length and area. We know we have already used this equation in the beginning of this video itself. So R is equal to rho into L by A. Here it is said that the copper wire is stretched by 5 times, means the length is actually increasing 5 times. So R dash, we can write it as R dash is equal to rho is the same into 5 times L, because we have stretched it 5 times, means L has changed to 5L, and the diameter is halved. Now we are expressing area in terms of A is equal to pi R square for a cylindrical conductor. Now this R square, pi R square, R means radius, can be written as R is equal to D by 2 the whole square, right? You can write area as pi D by 2 the whole square. Now we are saying that, or in the question it is said that the diameter is halved. So it has been made as D by 2 into 1 by 2 the whole square. So that is a new area, that is pi into D by 2 into 1 by 2. Again it is halved. The whole square is a new resistance. So R dash is equal to rho into 5L by pi into D by 2 into 1 by 2 the whole square. So you can write this 1 by 2 square and take it outside. You can write it as D by 2 the whole square into 1 by 4. So if you take this to the numerator, 1 by 4 to the numerator, it will be 5 into 4, which is equal to 20 times rho into L by pi by D the whole square. Now, again, you can write this pi D by 2 the whole square as area, which is the area of the conductor. So this is your new R dash, right? So how is the R dash changing? You can write R dash is equal to 20 times R, right? So it is increasing by 20 times is the answer. Okay, so the options given are diameter is half. That is, what is a change is they are asking. The change is actually an increase. It is a 20 times. Okay, the correct answer here is option B, which is 20 times is the increase. Okay, so the equation you use here is again R is equal to rho L by A, because the resistance depends on resistivity, length of the conductor and also area. Now in the question, most of the time they will be giving change in area as either increasing the diameter or decreasing the diameter likewise. So for that, you have to know this equation, area is equal to pi into D by 2 the whole square. Okay. So anyway, the correct answer here is option B is the correct answer. Moving on to the next question, I have written the equation for the question also in order to just make you familiarize it. The question is, the BJT has beta is equal to 50. Beta is current gain is 50. Has a base to collector leakage current. So if you don't understand what is a base to collector leakage current, they have also given in terms of the expression, that is ICBO. It is the reverse saturation of the leakage current as 2 2.5, sorry, I have erased it, 2.5 microampere. I'll write it here for you to see it more clearly. So the collector, base to collector leakage current is 2.5 microampere. Now the question is, if the transistor is connected in CE configuration, CE means common emitter configuration, what collector current for IB is equal to 0. See, the question is, we have been given beta is equal to 50. Also, collector, base to collector, reverse saturation current or leakage current is 2.5 microampere. Now, they are saying that we are going to connect this transistor is in common emitter mode. Common emitter mode we are going to connect. We need to find the value of collector current IC for base current IV is equal to 0. Now, we know that the relationship of IC and IB, in normal case, it is IC is equal to beta times IB, right? But since we have to consider the leakage current also, see here ICBO is a leakage current is also given. So when that is given in the question, that means you have to take into consideration the leakage current also. So now your collector current equation will get changed as IC is equal to beta IB plus ICEO. That is collector to emitter leakage current will also contribute to the total IC. And also they are saying that here IB is taken as 0, means your beta times IB will now get cancelled because IB is 0. So your IC is only contributed by the collector to emitter leakage current. Now what is the equation for ICEO? Since in the question ICBO is given, we can write ICEO in terms of ICBO as ICEO, that is collector to emitter leakage current is equal to 1 plus beta times ICBO is the relation. Please note this down if you don't know. Okay. So this is the relation. And now we can substitute IC is equal to ICEO, which is 1 plus beta times ICBO. Now you have beta, you have ICBO, so you can find collector current symbol, right? So what is beta? It is 50. So 1 plus 50 is 51. 51 into, your equation will change as 51 into 2.5 microampere is your current. And if you solve it, you will get the value as 0.1275 milliampere. IC will be obtained as 0.1275 milliampere is the value for your collector current. And the correct answer here is option B, which is 0.1275 milliampere is the answer. And I have also written the important equation for this. IC is equal to beta times IB plus ICEO, where ICEO is 1 plus beta times ICBO. Just for you to note this down. Also, this is another type of question which is now commonly getting seen in question papers. So that is why I have written this equation. Moving on to the next question. In a certain series resonance circuit, so again resonance has come into the picture. Resonance is very, very important for these competitive examination. There is a lot of concepts and also there is a lot of questions that can come. Okay, in a certain series resonance circuit, VC, that is voltage across capacitor, VC is equal to 125 volt, BL, which is the voltage across inductor. In the question paper also it is given like this. You have to figure out these things. VC is equal to 125 volt, BL equal to 125 volt, VR is equal to 40 volt. The source voltage is dash. Okay. In a series resonance circuit means the circuit is in resonance. And when the circuit is in resonance, the source voltage will be equal to the voltage across the resistance. Or the voltage across the resistance will now get changed as the voltage or given at the source side or the source voltage. Okay, so this is the condition at resonance. Please note this down. Source voltage is equal to voltage across resistance. Now why this is? Because in resonance the current is only contributed by the resistive element and it is a peak current. Okay, so what is the answer? It is nothing but VR will be the source voltage. And the correct answer is option D is the correct answer. The next set of questions is this. The effective channel length of MOSFET in saturation decreases with increase in dash. Okay, so the channel will get pinched off towards the drain and this, that is effective channel length will get varied or decreased due to the increase in drain voltage. That is why the channel is getting pitched off more towards the drain region. Okay. So the correct answer is option B, which is drain voltage. Moving on to the next question. Let me just remove this. If 211 to the base x is equal to 150 to the base of 8, what is x? So in order to solve these questions in general, the method we use is this: 2, 1, 1, and it is to the base x, right? So we write below this powers of x as x raised to 0, x raised to 1 and x raised to 2. Okay, on this side we write 1, 5, 2 and it is to the base of 8. So 8 raised to 0, 8 raised to 1 and 8 square. Now take the product of x square and 2, then form a equation. That is, you write like this: 2 multiply with this 2x square plus x raised to 1 into 1, that is x raised to 1, plus x raised to 0 is equal to 1 into 8 square plus 5 into 8 raised to 1 plus 2 into 8 raised to 0. Now if you solve it, you will get the integer value of x, a positive value and an integer value, and you have to choose that value as the value for x. Okay, I'll just simplify and show you. So it is 2x square plus x raised to 0 is 1. Okay, so you can write this as 2x square plus x plus 1 is equal to 64 plus 8 5s are 40 plus 2, right? You can take this to this side and it will be 64 plus 40 is 104 plus 1 is 105. So it will be 2x square plus x minus 105 is equal to 0. Right, this is your equation. It is a 2-degree equation. So you can solve it and find the value of x. You will get it as x is equal to 7 and x is equal to minus 7.5. So you cannot take the minus value. So for that you will take the value of x is equal to 7. So the answer for this question is x is equal to 7, and this is the general method you opt or you do for solving these type of questions. Okay, so the correct answer obtaining here is x is equal to 7 is the base of this 211. Correct answer is x is equal to 7. Moving on to the next question. If A and B are the inputs of a half adder, sum is dash. That is, you have to write the expression for sum. This is a very direct question. A and B, and that is logical and. B, A or B. C, A XOR B. D, A XNOR B. I'll draw the half adder here. If A and B are the two inputs, then the sum is contributed by the XOR gate, or you can write the sum like this. This is the sum. And the carry is the product. So this is a half adder, and the expression for sum is very obvious that it is A XOR B is the sum. And if the question was carry A into B, that is A and B. Okay. Anyway, the correct answer here is option C, which is A XOR B is the correct answer. Moving on to the next question. Whose complement of minus 74 in 8-bit is dash? So for answering such questions, that is, we need to find minus 74. First find plus 74 in binary 8 bits. Then take the 1's complement, add 1 to it. It will be 2's complement form. Very simple. I'll do it for you. So 2, it is 37. Remainder 0. 2, 18. Remainder is 1. 2, 9. Remainder is 0. 2, 4. Remainder is 1. 2, 2. Remainder is 0. 2, 1. Remainder is 0. This is the representation. I'll write it for you. 1, 0, 0. 1, 0, 1, 0. Right? 1, 0, 0, 1, 0, 1, 0. So this is the representation of 74. In how many bits it is? 1, 2, 3, 4, 5, 6, 7. There is only 7 bits. So for that, we will add a 0 here. This is the 8-bit representation of plus 74. Now convert it to 2's complement 4. Take all, that is take first 1's complement. Convert all 1's to zeros and zeros to 1. So 1, 0, 1, 0, 1, 1, 0, 1. This is the 1's complement. Add a 1 to it. 1 plus 1 is 0, carry 1, 1. Then 1, 0, 1, 1, 0, 1. This is your representation, and in the option, can you see any option like this? 1, 0, 1, 1, 0. Yes, option C is the correct answer for this question. So this is how you take 2's complement 4. That is, first take the positive numbers binary. In how many bits you want to represent C? If it is an 8 bits, convert to 8 bit. Okay. Then take the 1's complement. That is all. That is take the toggle of all the bits. 1's is there, make it as 0. 0 is there, make it as 1. Then add a 1 to it. Now you will get your 2's complement 4. Very simple, very straightforward question. Correct answer is option C is the correct answer. Moving on to the next question. It's a theory question. Switched capacitor filter is used to mimic the function of dash. Switched capacitor filter, I'll give you just a brief overview of switched capacitor filter. It consists of 2 switches. Generally, there is a capacitor, there is an input, there is an output side. So there is switch 1, switch 2. There are 2 switches and 1 capacitor. When the switch 1 is closed and switch 2 is open, that is when S1 is closed and S2 is open, capacitor will get charged. And when the reverse is happening, that is when S1 is open and S2 is closed, the charge will get discharged. Right? This is a very simple switched capacitor filter because it is having switches and capacitor. This is a basic structure. It can have advanced version also. Okay, so it is used for mimicking the function of resistors. It can be used in integrated circuit. These switched capacitor filters are used for restricting the flow of current, and it is used for the purpose of resistors or achieving the function of resistors. These switched capacitor filters can be used. Okay, so if you see such a question, that is, it is used to mimic the function of dash, means resistor is the answer. Okay. Minimum number of comparators required to build an 8-bit flash ADC. Okay, so this is a very direct question. So for 8-bit ADC, the number of comparators required is 2 raised to, generally if it is n bits, 2 raised to n minus 1. Okay, so it will be 2 raised to 8 minus 1, which is 256 minus 1, which is 255 comparators are required for the case of normal ADC and flash ADC. If this is a case of a folding type of ADC, this is for the case of flash ADCs. Okay, this is the equation. Now, the answer for this question is also 255. And if this is the case for a folding type of ADC, the number of comparators required is 2 raised to n by number of fold, which is m. This is another information I am passing. If n is a number of bits, then 2 raised to n by folds. Okay. Anyway, here the equation is 2 raised to n minus 1, which is 255 is the answer for this question. For 8-bit ADC, it requires 255 comparators. Moving on to the next question. I will remove this. The time period of 50 kilohertz sine wave is dash. It is 1 by 50 k. That is 1 by 5 into 10 raised to minus 4. Okay. 1 by 5 is 0.2. That is 0.2 into 10 raised to minus 4. Or you can write it as 20 into 10 raised to minus 6 or 20 microseconds. Okay, so from the options, the correct option was 20 microseconds. Anyway, this is a direct question. You just have to take the reciprocal of the frequency to find the period. Okay, so from the options, anyway, you will be finding the correct answer coming is 20 microseconds. For those who have answered this question, it is 20 microhertz and microseconds. And for those who are trying to study this question, just take the reciprocal of this frequency. Okay, you will be finding the answer and just adjust it to fix the unit. For example, micro or milli, like that. The answer coming here is 20 microseconds. Next question. So like this, a lot of very basic questions were there in the technical assistant question paper. And also there were some tricky questions also. Next question is, semiconductor diodes are not used for dash. A, low pass filter, B, voltage regulator, C, temperature measurements. And also the next option, there were one more option, I just skipped it, in diffusion operations or likewise. The semiconductors are generally not used for temperature measurements because they have a negative temperature coefficient of resistance. Okay, so when the temperature is increasing, the resistance will go very, very low and the current will increase to a very higher value. So generally they are not used for temperature measurements because we know that these semiconductor diodes are used for voltage regulation and low pass filter also, but they are generally not preferred for temperature measurements. Correct answer is option C is the correct answer. Next question. Let me remove this. A potential of 7 volt is applied to a silicon diode in series with a resistance of 1 kilo ohm. So there is a diode in series with a resistance and we are applying 7 volt. Okay. The value of resistance is 1 kilo ohm. The current through the diode is dash. Okay, the current through this diode will be equal to the current through this resistance because they are connected in series connection, right? Now, what is the current passing through this this resistance? So for that, we are applying a 7 volt here, right? So the 7 volt will be turning this diode as forward bias, and when the diode is forward bias, the voltage drop across the diode is 0.7 volt, right? We know that since it is a silicon diode, it is specifically given, the diode will have a voltage drop of 0.7 volt during the forward bias condition, and the remaining 6.3 volt will come across this resistance, right? So when this 6.3 volt is coming, what is the current passing through this 1K? It is 6.3 by 1K, which is 6.3 milliampere, right? And this current is equal to the current passing through the diode because they are in series connection. So the correct answer is 6.3 milliampere will be the current. Option C will be the correct answer. Next question. Moore's law is related to dash. I have skipped the options because the options were speed of working of the device and various other factors. But Moore's law, we are studying this as a basics of VLSI design. Moore's law is dealing with the level of integration of MOS structures, metal oxide structures. That is, due to this Moore's law, the VLSI technology is actually developing. We are integrating a lot of things together onto a single miniature size chip. It is a level of integration it is dealing with. We have studied the Moore's curve and all, right? So, Moore's law is related to the level of integration of your MOS structures. Okay. So, the correct answer is level of integration of MOS structures. Okay, so these are the questions which I have included in this video. There will be one more part of the solution videos, and in each part, as I'm saying in all my videos, I'm not just trying to say the answers, I'm just trying to include some more additional information as possible. Okay, so we'll wind up this session of solutions with the next part, which will be the last part of this series of solutions of LPSC Technical Assistant. So there is a lot of other examinations is also coming for URSC, that is another technical assistant recruitment has been that means another notification is out. So the application date is till March first week. So I hope that you are applying for that. Also there is a lot of vacancies for technical assistant in ISRO. For electronics branch also there is 17 vacancies there. So if you have not applied, please do apply for this for that post. Okay. The vacancies or the application link is now open and you are able to apply. Okay, so the qualification is first class diploma in electronics. I'm talking specifically for the electronics branch. Okay, so that's all for this video. I hope that you found this video useful for your preparation. If yes, please do give it a thumbs up and also share these videos maximum with friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.